Hey everyone, today I'm going to walk through a full chi-square independence FRQ, step by step, just like you might see on the AP statistics exam. By the end of this video, you should be able to recognize when to use a chi-square test of independence, write hypothesis correctly, check all required conditions, calculate expected counts, compute chi-square statistic, interpret the p-value, and write a strong conclusion in text. So a lot of students struggle with the chi-square test because there's several steps to it and the wording can get a little confusing. But once you understand the logic behind the test, it becomes a whole heck of a lot easier. So the main idea is pretty simple. We're just trying to determine whether two categorical variables are related to each other. So I have an example. We're going to be observing whether a rocket launch and seeing the rocket launch is going to increase or not increase the interest in astrology. So this is the chart. If you want to pause, you can to draw this on your own piece of paper. So we have observed launch, did not observe launch, increased interest, no increased interest. So for this one, for the students that observed the launch, 68 increased interest and 332 did not increase interest. And for the students that did not observe the launch, 59 interest increased and 301 did not increase. So at a first glance, you might look at these numbers and think, oh, they're pretty similar, so they're probably probably doesn't matter too much to do a test to figure out what they're like, how different they are. But in statistics, we have to use the statistical test to determine whether the differences we see are large enough to be considered significant. So one of the most important things to understand this unit is understanding independence. Two variables are independent if one variable does not affect the other. That's pretty much the definition. So for example, if observing a rocket launch has no relations with increased interest in astronomy, then the variables are independent, right? But if students who observe the launches are noticeably more interested in astronomy afterwards, then the variables are associated. This is important to the chi-square test because it compares like what we actually observed to what we expected to see if the variables were independent. So like later on in this video, you'll see that that depending on the outcome of the test, it will show us exactly how it corresponds to the independence of both ones. So why this test works is because it uses the information that we know, given the sample size and the data that it gives us, to create the number and the statistics of the differences in the observed versus did not observe categories to determine what numbers exactly would be if they were independent or not independent. And we can see from those two tests that if one is different than the other, then they're independent. So for example, if a rocket launch truly has no effect on the percentage of students interested in astronomy, it should be similar whether they observe the launch or not. So if the rocket launch had no effect, the numbers should be similar. The numbers that observed versus did not observe should be the same. But if viewing the rocket launch did affect it, then the numbers would be different. So the chi-squared test checks whether the difference is between observed counts and expected counts are bigger than what we normally expect from random chance. So small differences suggest independence, while large differences suggest association. Okay. So for this part of the FRQ, you're gonna be given the chart, and you're gonna be given a paragraph of the information. But for right now, all we need to worry about is these two parts right here. So we're gonna be writing the hypothesis. So the first one we're gonna writing is the null hypothesis. So H down subscript thing, I think O, and then two dots, and then you're gonna be writing. This is the same for every single chi-square independence FRQ, but it's just gonna be different because of context. So you're gonna be writing, there is no association between observing a rocket launch and increased interest in astronomy. So for this part, all you need to remember is that there is no association between, and then the rest of it is context. So like, for example, if the question's about baseball, you have to write it about baseball, seeing a baseball game, or if it's about something else, you write there. And then for the second hypothesis is the alternative hypothesis. So H and then A. So after you write that, then you write there is a association between observing a rocket launch and increased interest in astronomy. So after you write those two down, you should be pretty much good, except for the fact that you also have to include on the top of your FRQ chi-square independence test. You have to write that at the very top. And the second part you're gonna be doing, after that you'd write you draw your fish equals 0.05. So the first real step is to name it. So you're gonna do chi-square independence. And then after that, next is you're gonna write do fish 0.05. And then after that, you will write your two hypotheses. And for that second part of the FRQ, you are done. Okay, I'm gonna erase this. For the second part, the FRQ, it's going to be the check part. Okay, so there's three parts of check. There's random, independence, and normal. So for random, what we're going to be doing is we're going to take so normally there would be a paragraph type thing of the question, but for this one I did not include that. So in a real FRQ, you would go in the paragraph and find the place where it says random. It says random, and you find it has to have you put some quotes here, and then you write the exact quote. from the thing. So for me, I have a little sentence here that would consider my paragraph part of the thing, the question, that says 760 students were randomly assigned or selected. And then for random, you're done. You're good with that one. Next step is independence. So for independence, what you're going to be using for this one is the 10% condition. So you're going to write You're going to write 10% condition. Then after that, you're going to take the total number of students, which is 760, right? And then you're going to write 6, 8, which is the increased. Actually, no, that's wrong. You're going to write 760 is less than or greater to 10% or 1/10 all students. And then for that step, you are going to be done. So moving on to normal. Normal is a little different. Scroll down. So we're going to be using expected counts for this one, not the other one. Okay. For this one, you're going to go into your calculator. And we're going to be using calculator steps now. Okay. The first part of the calculating step is you're going to be going to doc, which is this one right here. Select it, and then you're going to go to the letters, and you're just going to put 3 letters. You think that would be good? So for me, I'm going to put observed O, and then spaceship L, S, and then launch L. So you're going to put 3 letters just like that. After that, you're going to go over to, you're going to hit the control button, and you're going to come over here to these 2 buttons and click the one on the left. And it's going to input some dots and equal marks. After that, you're going to press the same button, and it's going to open up this little thing. You're going to navigate your way to the one that looks like a 9-block square, a 3x3. You're going to select it, and it's going to come up with create a matrix. You're then going to change it to be 2 rows and 2 columns, and then select enter. It's going to pull up like this. So from there, you're going to input your information just like the graph. 68, 59, 332, and 301. And you're going to press enter. And it's going to give you some new numbers. So for the normal part of the check, you're going to write those numbers. So you're going to write you're going to make another little graph that's just like this. You can make it smaller, you can abbreviate words, you can do everything. You can do stuff like that. But you're just making another graph. And you're gonna put the numbers in. No. You're going to make a that graph, yes, but you'd still have this. You don't put those numbers in. Then you go to menu, 6, 7, 8, and then you're going to select the OSL, the one that the thing that you, whatever, however you named it, and you're gonna press OK. It's going to give you this drop down of a bunch of different information that you need, and you're going to be using this for later in the question. After this, you're going to go to var, and then you're going to scroll down to, oh, my bad, to expected matrix. Then you're going to press that, and then you're gonna press enter. And it's gonna give you these new numbers. Okay, and they're gonna be similar, but they're still different. So from there, you're gonna go in here and write them. So the numbers that I got were 66.8, 60.1, 333.1, 299.8. Okay, so now, okay, also, then you have to write all expected counts, or EC, is greater than 5. Now after you're done with that, you are done with the full check part. If you get all this information down, then you got full points on the check. Okay, let me get to the next part. Okay, next part of the FRQ that we're working on is the calculate portion. So the first step is going to draw. So first you're going to draw a graph that's skewed to the right. After that, you're going to shade in this bottom portion, and then you're going to be writing. You're going to do your different DF. You're going to do this over here. Chai, and then you're going to write parentheses DF equals the amount of rows minus 1, so we have 2 minus 1 times the amount of columns minus 1, so 2 minus 1, which equals to 1. So you're gonna write it like that. And then under this draw, you're gonna write another chai, and then you're gonna equal it to, we'll leave that blank for now. Okay. So then after that, we come over here and draw and then you're going to go, so for this part, you're going to write the first column and the last column. And then you don't have to write the things in between. So first thing you're going to write is 68 minus 66.8, which is the number that we got from the past calculation, the check step. And then you divide it all by 66.8. Okay, then you do comma, dot, dot, dot. And then you're gonna do the same thing, but with the box on the bottom right. You're at 301 minus 299.8 divided by 299. And you're gonna equal this to, you're gonna go back on your calculator and you're gonna find the number on here in the little drop down thing. It says 0.05, 0.0508. You're gonna equal that to that. You're gonna come back over here and write the same thing. 0.0508. So right now it should look like this. Then after that, we're going to be finding the probability. So then you write P, parentheses, chi-squared, greater than 0.0508, parentheses, equals, and then you're going to go back onto here, onto the calculator, right below the 0.0508, you're going to find the p-value, which you're going to write here, and it is 0.8216. So then your calculate step should look exactly like this. So first step, draw. Second step, DF. Third step is to create your list and then find the number in the calculator. And you're gonna put it over here as well. And then write your p-value work and then find in the calculator for the final value. And that is the calculate step. Okay, the last and final step of this FRQ is the conclusion. Okay, so for the end, you're gonna remember, going back to remember what we need is fish is equal to 0.05. Okay, so we have to go back to that. And then we also have to know the information that is our p-value. So our p-value is p equals 0.8216, right? Yeah. Okay, these are the two pieces of information that you need. So you're going to start it off with because. You write because, p-value, 0.8216. You're going to write the p-value. It's greater than fish, 0.05. We do not convincing evidence that there is an association. It's like taking the information from the hypothesis and pretty much rewriting it. between the observed between observing a rocket and increased increased astrology interest. Okay. Because p-value 0.821 is greater than fish 0.05, we do not have convincing evidence that there is an association between the observing a rocket launch and increased astrology exists. Okay. So then the final part is going to be saying we failed to reject them all.
But her carrots and her vitamins are in there. She's had her vitamins today. Okay. See, you're so happy. She was so hot. Sorry.
And that's the final sentence of the FRQ. So.
Yes.